Hello students. Let's look at some density calculations. So in this first problem, if a urine sample has a mass of 122 grams and a volume of 121 milliliters, what is its density in grams per milliliter? Well, let's remember our math equation for density, where D is equal to M divided by V. D is the density, M is the mass, V is the volume. And so we have a mass that is 122 grams, so that's going up top, and a volume that's 121 milliliters, so that goes on bottom. So you divide the 122 by the 121 and you get 1.01 grams per milliliter. Okay, so we're going to report our answer to 3 sig figs, since we have 3 sig figs here and 3 sig figs here. Alright, straightforward calculation, right? Sometimes some problems may involve converting the mass to grams, or converting the volume to milliliters or centimeters cubed, what have you. So just be on the lookout for that. Alright. In our next problem, we have isooctane, which is a high octane component of gasoline. And they say if the density of isooctane is 0.692 grams per milliliter, how much does 220 milliliters weigh? Alright, our density equation, D equal to M divided by V, we're going to rearrange our density equation so that we solve for the mass. So we would just multiply the volume on both sides. That would get rid of the volume on this side and leave us with mass is equal to the density times the volume, or M is equal to D times V. And so the mass is equal to 0.692 grams per milliliter, that's our density, times 220 milliliters, that's our volume. So the milliliters cancel, thus leave us with grams, so we get 152 grams. So for 220 milliliters of octane, we have 152 grams of octane. Alright, so if we have the mass of a substance, in order to get to the volume of that substance, to know the volume of that substance, we have to know the density. And if we have a volume of a particular substance and we want to know what the mass of that substance is, then we have to know the density in order to make those conversions between mass and volume. Okay. Alright, in this next problem, we have the density of sucrose, which is table sugar, is 1.56 grams per cc, which is cubic centimeters. Alright, what is the volume in cubic centimeters, or what volume in cubic centimeters does 20.0 grams of sucrose occupy? Again, we're going to make use of our density equation. D is equal to M divided by V. In this case, we're looking for volume, so we need to cross multiply. So volume goes on this side of the equal sign, and density will go down into the denominator on the opposite side. And so to calculate volume, we say V is equal to M divided by D. Okay, so 20.0 grams divided by the density, which is 1.56 grams per milliliter. So that milliliter will flip up into the numerator, so we can express it like this. Okay, because after all, that's what we're looking for, the volume, and so it can be expressed in this way. So we divide the mass by the density, right? So grams cancel, so 20.0 divided by 1.56. Alright, that's going to give us 12.8 milliliters. But the problem said reported in cc. So just remember that 1 milliliter is equal to 1 cubic centimeter. Okay, So whatever I am in milliliters, I'm going to be that same thing in cubic centimeters. So this would be 12.8 cubic centimeters, or 12.8 cc's. Okay, on to some specific gravity problems, also known as relative density. So in the first problem, which of the following liquids is the upper level when added to water? Well, let's remember what the density of water is. It's 1.00 grams per milliliter. And so if I have a liquid that is less dense than water, that has a density lower than that, then it will float on top of water. Okay, so it will be the upper level in this case. So if we compare this density to this density, the density of olive oil to the density of chloroform, what we find is that olive oil has a density that is less than the density of water, and so we would expect it to be the upper layer or upper level. Okay, chloroform has a higher density than water, so we would expect in that case chloroform to be the lower level, and then water would be the upper level. Okay. All right. In this problem, what is the specific gravity of mercury if it has a density of 13.6 grams per milliliter? Well, recall what specific gravity is. It's the density of the substance divided by the density of water. So whatever the density of that substance is, it's going to be numerically the same for the specific gravity. It's just specific gravity is a dimensionless number. So what we do is we say 13.6 grams per milliliter divided by 1.00 grams per milliliter, and that gives us 13.6. So the specific gravity of mercury is 13.6. Okay. Last problem. What is the density of ethanol if it has a specific gravity of 0.789? Well, recall what specific gravity is. It's just the ratio. It's just the ratio of density of your substance to the density of water. And it's a dimensionless number. So if I want to know what the density is, I just tack on the density units here. So it's numerically it's the same, right? It's 0.789 is the specific gravity, then the density is 0.789 grams per milliliter. So that's just a quick, fast way. Just tack on some density units to your specific gravity, okay? And that'll get you in density. All right. So I hope this video was helpful, and as always, happy studies.